Welcome back, students, to our Chemistry 1510 video notes. In this video, we're going to start talking about matter as well as phase changes. So we have already defined matter earlier, and now we're going to go a step further and put pictures behind what matter looks like when it's in its different phases. So of course, there are the three phases that we are most commonly aware of: the solid, liquid, and gas. And here are some pictures here that show how atoms are arranged when we're looking at those three different states of matter. Notice how the gas molecules are far apart, right? So these are far apart, and this little line thingy is meant to indicate quite a bit of movement. Your liquids, on the other hand, have molecules that are much closer together, or atoms that are much closer together. And they are not ordered, right? They're not set up in this very systematic fashion, which is what you see with solids. So solids, notice how we can make, columns or rows that are very ordered, and these are in a fixed location. These particles can't move very much at all, but they still move because they vibrate. So if we had to rank our molecular motion, your gases would move the most, and your solids move the least. Sometimes it's easy to get caught up in a mental trap of thinking that the particles that make up a solid don't move at all, and that's not true. Molecular motion ceases at negative 273 degrees Celsius, which is absolute zero. And we haven't gotten there yet. We've gotten close, but not there. So every single time you encounter something in real life, whether it is a solid, a liquid, or a gas, the particles that make up that thing are moving. They might be moving quickly, or they might just be vibrating. So if we start to think about the pictures that we see there, and we think about how many of these are compressible. So if you take a solid and you try and compress it with a hydraulic press and make it smaller, it's not going to work. The gases are the only ones that are compressible to the point where we care, right? The compressibility of gases is essentially the reasons why you have cars. Why you have gasoline-powered cars. We will consider liquids, which are only very, very slightly compressible. We're going to consider them in this class incompressible, along with solids. So your liquids, like you learned in grade school, and your gases kind of take the shape of their container, and your solids do not. So let's move on to physical and chemical changes. Then we're going to go to physical and chemical properties. So a physical change and a chemical change, they're really difficult to distinguish between physical property and chemical property, but we'll do our best. So when we're talking about a physical change, we're not changing the identity of the compound or the atom. All that we're doing is changing its state, in a sense, right? So melting, condensing, freezing, dissolving is a physical change, right? If you mix salt, NaCl, and water, you get salt water. It's still salt and water. They haven't made anything new. So these are examples of changes that can happen that we would describe as physical. When a change occurs and the change results in a different chemical compound at the end, then we know a chemical change has happened. So if you add two things together and you see a gas produced by seeing bubbles or fizzing, you know you had a chemical change. If all of a sudden you add two clear, colorless solutions together, right? Here's a beaker, or I'm sorry, my brain stopped working. A test tube. Here's a test tube. They're both filled with clear, colorless liquids. You add them together and all of a sudden you have a purple liquid, or you have something that looks like there's solid particles in there, or you have something that is looks cloudy. That's definitely a chemical change. So if it looks cloudy, that's a precipitate. If you see a color change that you weren't expecting, so one that's not based upon the color wheel, that would be an example of a chemical change. And of course, heat or light being produced, like when you burn wood, right? That is a chemical change. So I want to give you a moment here to look at these two questions and pause and decide whether or not they are chemical or physical changes. All right, so here we are. I've written out whether this is a chemical C or a physical P change. So the ones that usually get people are this one and, well, we already said burning wood releases heat, but sometimes that still gets people. So let's talk about these two. So the first one here, silver nitrate and sodium chloride mix to form a white solid. Sometimes this one's really difficult because it comes earlier than what you're expecting for a chemistry class, right? We haven't learned what silver nitrate and sodium chloride are, and you don't know what they look like. But whenever you see something that says to form a white solid or to form something else, it means that there was a chemical change. The other one that gets people is wood releasing heat. I have had students argue with me and tell me that this is absolutely a physical change because burning wood is a physical change. Well, here's the problem. Can you get that ash at the bottom of your fireplace and turn it back into a log? No, you can't. And so that is why burning things is going to be a chemical change. Transition now to chemical and physical properties. So for your chemical and physical properties, these are characteristics of the material. So that's what makes it so difficult to distinguish between chemical and physical changes and chemical and physical properties. When you're a new chemistry student, it's almost indistinguishable, right? You either just call it chemical or physical, and we leave off the word property or change. But notice the slight difference in wording here, right? The physical properties are a characteristic of the material. It's not something that's actually happening. So something like your melting point is a physical property. Whereas when we were talking about the process of melting, that was a physical change. So there's a super slight distinction there. Whereas chemical properties are, again, something related to that chemical. So the fact that, silver nitrate reacts with hydrochloric acid to form some white solid, that was your chemical change. Just stating that the silver chloride reacts with hydrochloric acid would be a chemical property. So you can maybe see why we don't spend a lot of time distinguishing between changes in property is because they're so related to one another. So for this first one, I want to go through the example with you and then give you a moment to do the question yourself. So for the example, stating that water is a clear, colorless liquid at 20 degrees Celsius, that relates to the physical characteristics of water, and so that's going to be a physical property. Stating that sugar dissolves in water is, again, a physical property. Because remember, dissolving, the process of dissolving was a physical change. So stating that sugar dissolves in water is a physical property. Water being produced as a gas when allowed, oh, I'm sorry, I read this wrong. Water produces a gas when allowed to react with calcium metal. See how it says react there? That's your key that this is a chemical property. So pause for a moment, look at the next three, and decide whether they're chemical or whether they're physical. All right, so you took a moment, you looked them over, and here we are, physical, chemical, physical, right? Density and color are physical properties. We see the word react from letter B, we automatically know we're talking about a chemical change. So the last section of this video is going to be classification of matter. So I'm going to say a bunch of stuff on this page and just note that it's summarized in words on the top of the next page. So we've already defined matter here, and now what we're going to do is separate matter into the different components. What I mean by that is matter could be pure substances. That would be things that are atoms, things that are molecules, or when we get a little bit further along and we learn what a formula unit is, right? All of those would be pure substances. So molecules are covalent compounds. Formula units are like the ionic version of a molecule. So we're talking about atoms, molecules, and ionic compounds. Mixtures are going to be, maybe you have water and ethanol mixed together. So you have two different components that just happen to be in the same flask, and they're not chemically bound to one another. So maybe you have a mixture of two types of atoms, or maybe you have an atom mixed with a compound. And you know what? I'm going to take this and just simplify it right now and call these compounds. I think that'll be better for you. Then your mixtures, you can always separate them. Think about if you had a pot. That's my handle. And your pot had water and sodium chloride, salt, mixed in with it. If you let that pot sit on the stove on low all day long, at the end of the day, all of your water would be gone, and there would just be white powder at the bottom of your pot because you physically separated the water from the sodium chloride. The water evaporated and the sodium chloride's at the bottom of the pot. So mixtures are things that you can separate. There are two types of mixtures. There are heterogeneous, which means the same throughout, and homogeneous. No, I did that backward. Homogeneous, right? Homo is same. So same throughout. And the heterogeneous mixture is sometimes like a mixture of two phases, right? So these are, what is the word I'm looking for? So maybe they have different phases. the two components are separated somehow, like oil and water. Maybe it's like when I make a pizza for my children and this side has to just have cheese and this side has whatever the adults want. Wow, I really need to go to bed. It's pretty bad when you can't spell adults. So they're not the same throughout. Now, for pure substances, we already talked about how you can separate this into elements, right? Where atoms are the smallest unit of your element, and your compounds are going to either be ionic or covalent. The smallest component of a covalent compound is called a molecule. The smallest component of an ionic compound is called a formula unit. Elements are things that are on the periodic table, and elements, their smallest component are atoms. So let's see if we have some questions here on the next page. So here we have all of what I just said out loud, kind of typed out so that you can go through it. And nice, good examples. Oh, here, this looks better. A mixture in which the properties vary within the sample. Yeah, that's a lot nicer than what I came up with. So why don't you take a moment, look at these, and decide, are these elements, compounds, heterogeneous mixtures, or homogeneous mixtures? Okay, so we're back. I have written out the answers to these, and I want to go through the couple that are, I guess, arguable, right? So first of all, air. I just wrote mixture here. And I wrote mixture because depending upon kind of where you're looking depends upon if you're calling this homogeneous or heterogeneous. So if you're imagining the room that you're in right now, you could argue that air is a homogeneous mixture because the room probably has the same composition throughout it. Now, someone else could argue that right next to your mouth where you're exhaling, there's going to be a greater amount of carbon dioxide. And so in actuality, maybe it is a heterogeneous mixture in that room. And then someone else could be considering the different layers of the atmosphere, right? At sea level and 1,000 feet above sea level have different air compositions of the oxygen in the air. And so you have to kind of define what you're looking at in order to get an idea as this is a homogeneous or heterogeneous mixture. Another one that students stumble with is gold, because you're unaware of the carat system. So in the carat system, 24 karat gold is pure gold. So that would make 24 karat gold an element. So knowing that 24 karat gold is pure gold, then maybe we can deduce that 10 karat gold is a homogeneous mixture. And what they do to make things like 10 or 14 karat gold is they mix gold with some other metal that is harder, right? It's less malleable. And that way your jewelry doesn't bend. Because really none of us have 24 karat gold jewelry. That'd be really dumb. It would bend out of shape with no effort at all, and then we would be sad. Another one that students struggle with is brass, mostly because brass has fallen out of use recently. And maybe not recently, I think it was a while ago. If you go through an old house where nothing's been updated in like 40 years, everything is brass. And personally, I don't really care for brass, and you probably don't either. But brass is an alloy. It's a mixture of two metals. How do I know it's a homogeneous mixture? Well, when I look at a door handle, I don't see swirls of one metal and then swirls of the other metal through my door handle. It all looks like one component. And so that's how I know it's a homogeneous mixture. Milk is another one that students struggle with because we can again argue, right? Some folks will automatically say it's homogeneous because they are thinking of the milk at the grocery store, which is homogenized, right? So it's homogeneous. But if you've ever like milked a cow and seen what comes out, it separates, right, into the cream and the milk. And so in that case, that milk is very different because all the fat floats to the top. So it would depend. You'd need more information to classify this. Milk from a cow, heterogeneous. Milk that's gone to a processing plant and been homogenized, homogeneous. Another one that students struggle with is a vitamin C tablet, mostly because we're unaware of what is in the tablet that we're taking. People, honest to goodness, think it's 100% vitamin C, and that is simply false. When you get a tablet that's the size of your thumbnail, and it says there's, 500 milligrams of vitamin C in it, there's no way that that tablet is completely vitamin C. It has way too much mass. And so that tablet, if it's chewable, is probably contains some sugar and some other things. If it's not chewable, it contains starches as binders. So no vitamin or supplement or medicine that you take is pure. They're all mixtures. And in the case of a vitamin C tablet, it is indeed homogeneous mixture. And then the last one, just for fun, vodka, is a mixture of ethanol and water. And you know that that's homogeneous because you don't see any separation. If it was heterogeneous, it would look like oil and water, right? If you've ever seen a salad dressing, you go to Meijer, you look at the salad dressing section, and you see that Italian salad dressing has these two layers here. So that would be a heterogeneous mixture. But if you're 21 and over and you know what vodka looks like, it is a homogeneous mixture. Well, that's enough for this video. Thank you so much for your attention. This is Katoni signing out.